Okay, let's talk about graphing tangent and cotangent. All right, so here's the basic picture of them. Now, tangent and cotangent look very, very similar. One difference is that tangent is going, upwards from left to right, and cotangent is looking like it's decreasing, going down from left to right. Notice, though, that they both have asymptotes, and that their little snake line curvy thing lies in between asymptotes. Also notice that it takes less time to do a repeating pattern. So between here and here is a cycle because that exact same thing is what's going to happen next. Now, as far as cotangent's concerned, it's this one right here, and then that picture gets cookie cut and stamped throughout the rest of it. So we actually have a smaller period. It's actually only a basic period of pi because it takes half as long. This one looks weird, but we've gone half pi this way plus half pi this way, so your total period is pi. And that's one of the weird things about tangent, but other than that, asymptotes, you've got 3 points to graph, and then you connect the dots, and that's it. So let's talk about the 3 of the special points. So you've got your asymptotes, told you about those already. This is an asymptote. Here's your 3 special points. There is an intercept directly in between those 2 asymptotes. So once you've got your asymptotes up, go halfway between and put an intercept. It doesn't have to be on the y-axis, it's just an x-intercept. Okay, and then the other special points are the other 2 lines. So one to the right, one to the left, and then you go up the amplitude. Technically, there's no amplitude because there's no maximums or minimums in this, guys, but that's where that, and I always use air quotes, quote unquote, amplitude is going to go. That's the measurement of it. So the first point, you've got an asymptote. The second line will go to an amplitude or negative amplitude. Third one is an intercept. Fourth one is an amplitude again. And the last one is an asymptote. Exact same pattern for cotangent, asymptote, special point. This one is at the positive amplitude this time. So amp, positive direction. So asymptote, amplitude, intercept, negative amplitude, meaning we're going down, and then your asymptote again. So special points are at your amplitudes. Technically, it's not an amplitude, but it will still be called A in your formula. And then the other point is between the start and middle and between the middle and end. This thing's really tripping out on me today. Between the middle and the end. That's kind of the basis of tangent, is figure out your labels on your axes, draw in your 2 asymptotes, put your intercept in the middle, find your other 2 special points, and connect the dots. That's what happened. I knew something got moved. That point right there. Okay. Let's talk a little bit about what happens when that amplitude, quote unquote, is put in there, the differences that it makes. All it does is increase or decrease these special points. So originally it was here, now it's been amplified or stretched, to a different point. So I keep saying so. When you go to graph these, this point right here changes those special points, and that's it. Makes the curve either squished, that's not a word, shrunken down where it's closer to the x-axis, or maybe it made it skinnier by dragging the ends up. Now, when you have a number inside as well, the B number, that still affects your period. The difference is now your formula is just pi divided by B. Remember, tangent and cotangent only took one cycle before it started repeating. So it only takes half as long to make a full cycle, if those words are making sense. Anyways, let's get down to it. So you're going to be given these. We're not going to worry about phase shifts for this one. We're just going to be worried about finding the period based off of that B, finding the quote-unquote amplitude by the A, and any kind of shifts up or down. It's no longer a midline. I mean, you could call it a midline still, I guess, but these are basically just moving the graph up or down, and it works like any other graph. You go, okay, here I'm done with my graph. I need to move everything up one. Okay, pick this point up one, put it down. This point, okay, connect my dots. The asymptotes don't change. Okay, first step you're going to do, you're going to find your asymptotes and sketch on the graph. That is your beginning points, is those asymptotes. So once you've got your period, your P, the tangent asymptotes go at plus or minus P over 2. So take your period over 2. There's going to be one at negative P over 2, and then one at positive P over 2. For example, this one right here, I've got a B of 1/2. So my period would be 2 pi. Nope. Psych, number one mistake people make on these. See how easily I made it? Pi divided by 1/2. That's pi times 2 over 1, or 2 pi. Okay, we found our period. Now we're going to have to figure out where our asymptotes are. So for cotangent, it happens at 0 and the period. So 0 is your asymptotes. Just make that nice and thick. And then just like before, you count out 4 lines. 1, 2, 3, 4. And that's where your second asymptote's going to go. And then, of course, you can label in these numbers as we go. So let's see, it was at 0 in the period. The period was 2 pi. So right here is 2 pi. And to fill in the rest of them, why did you move? There's pi, 3 pi over 2, and pi over 2. Okay, once the asymptotes are in, you're going to put in your intercepts. Here's the best part about intercepts. Here's an asymptote, halfway in between, intercept. Done. Asymptote, halfway in between is your intercepts. Okay, now the special points. Now this is the amplitude, quote unquote, part of it. So like in sine, you would have went up to the amplitude and then down to the negative amplitude. Same idea here, but it happens at this point right here. You're going to go up to the amplitude on the left and down on the right. You've just got to picture what cotangent looks like to help you remember which one's which. So I need to label my y-axis. I've got a quote-unquote amplitude of 2. So I need to at least go up to 2 and down to negative 2. Okay, got our asymptotes, got our intercept. At this first point right here, pi halves, since it's cotangent, I'm going to go up to the A, the amplitude, and put a point. And then I go over to this other middle spot between middle and end, and I go down to negative 2 and put a spot. Now, these graphs have asymptotes, which means your graph is actually riding closer and closer and closer to this guy up and forever into infinity. But right about here, it makes this little curve and then goes down there as well. These cannot be drawn like this. Don't give me graphs like this. Those aren't tangent graphs. Tangents have a little curve to them. And I know they're not going to be perfect, especially the ones that are really stretched out, but make sure you put some curve in there. Let's try another one. Okay, 2 tangent of 3x. We're going to name the period, easy, p equals pi over b, which is 3. The asymptotes, okay, the asymptotes for tangent happen at plus or minus p over 2. So let's figure out what p over 2 is. That would be pi thirds divided by 2. I don't like fractions inside of fractions. Okay, if you don't quit moving on the screen. That is pi over 3 times 1/2, which is pi over 6. All right, so on our graph, you are going to, for tangent, your intercepts, or sorry, your asymptotes are going to happen at plus or minus pi 6. Now it goes out 2 lines in each direction before your asymptote happens. It can't happen here because then we don't have any spot to put our special points. So it's always 2 to the left and 2 to the right. It's balanced so that there's still 4, but instead of just 4 to the right, you're going to go 2 left and 2 right. Okay, I don't even have to put in the rest of the x labels yet because I know the intercept's going to go right here. In between the 2 asymptotes, intercept dead smack in the middle. Now if we put our values on, if this right here is negative pi 6, and this is positive pi 6, what is this one going to be? Well, it's going to be half in between those guys right there. So this is where p over 4 comes into play. You still need to know this first number to count by. So you would still do period divided by 4. That's pi over 3 times 1 over 4, or pi 12ths. So this will be positive pi 12ths and negative pi 12ths. And then we've got a quote-unquote amplitude of 2. So I'm going to go up 2 lines. So we've got -2, -1, 1, and 2. Okay, I've got asymptotes. I've got my intercept. Now I'm going to put in those special points. So I've got something here, something here, something here. I have 2 more lines that I have to put something on. It is tangent, which means it's supposed to have this shape. So this special point on negative pi over 2 must be down here at -2, according to the amplitude. And then this one on the right is up here at +2. And then to connect the dots, remember it rides along the asymptote, curls, 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 and looks something like that. I didn't name all the pieces, but they're there. Let's try one with a shift. So this one has a vertical shift. It's been moved up. Now, I'm going to pause.